Welcome, Velociraptors! Today we will be reviewing the nuts and bolts of completing a bird project in Planet Earth. Before I get started, feel free to download this presentation to take notes on. You might also want to reference your organism handout, which is located in the Resources module on Blend. Let's get started. Before you get started with your study, you will first need to make some choices. First, you will want to locate a natural area near your home. This might be a park or green belt. Check out the park locations on the introduction to the project presentation for help. If you choose a location not listed, make sure to review that with me first to make sure it is suitable. Second, you will be choosing a bird to study. We will be going through the choices in just a moment. However, to help you decide, you are going to want to visit your location first to see what birds you hear. This will give you a pretty good insight into what bird to choose. Make sure to visit your park in the early morning, because this is when the birds will be the most active, and when you will be collecting future data sets. Remember that you are in a group, so you need to make sure that the study bird you choose is a good candidate for all group members. You have the option of choosing between the northern cardinal, northern mockingbird, Carolina wren, blue jay, Carolina chickadee, or the tip mouse. For this workshop, we will provide you with an overview of each of the species and how to identify them. Once you have decided, you will then work hard to become an expert on your species, which you will later present as a natural history as part of the project. Let's get started learning about birds. Take a look at this unique species of bird perched in the perfect position. This is probably not how you're going to visualize them in the field, because they are usually bouncing around. However, it is easier to analyze this way for demonstration purposes. Take a moment to write down some key characteristics and that the species that you can identify. The first thing that many people are drawn to is this bright reddish crest. That is an excellent field mark. However, it is usually not easy to see in the wild. You might also have written something about the bird's beak. Also a great point, but still difficult to see in the field. What field marks would be easily identifiable in the field? One example would be the wing bars. That is something that is easier to visualize in the field. In addition, if you take a closer look at the eyes, you'll see a white area surrounding the eye. Another great way to identify this particular bird in the field. Something that is hard to tell from this image is its general size and behavior, which will also help you. For instance, this particular bird is tiny and is rarely sitting still. It is usually bouncing about and twitching. This is a ruby-crowned kinglet. As you learn more and more about your bird, you are going to want to put together a list of field marks that your bird exhibits that can be quickly observed to help identify your bird, especially given that you will only be seeing it for a quick blur. You can locate a majority of this information using the Cornel Lab of Ornithology, which is linked in the video description and in the Resources module on Blend. There you will be able to take the next step in becoming an expert on your bird. If you see a reference to a part of the bird you're not familiar with, or referenced differently, make sure to check out the Cornell's Bird ID Skills Field Marks discussion, which is also linked in the Resources module. Visually identifying your bird in the field can be challenging. Thus, most of the time you'll be using something else: sound. Songbirds have two primary vocalizations: songs and calls. When a bird is singing, we refer to this as a song. They use this to establish territory or for mating purposes. That is why they are generally more pleasant. However, calls are normally used to signal danger or scare things away. That is why they are typically very harsh. For your bird, you will need to be able to identify its song and call accurately so that you can identify it in the field. Now that we know about field marks and the vocalizations that songbirds create, we want to investigate our 6 different study birds. Our first bird of choice, which you probably guessed based on its coloration, is a blue jay. This coloration might be easy to see from this image, but can be challenging to use in the field. Thus, we need to be able to identify some other significant field marks. For instance, we see that they have a white wing bar. They have these characteristic white corners as part of their tails. Around their neck, we see a black line. This is called a necklace. In addition, we also see this sort of dashed pattern or shingled look to its feathers. All great IDs to use in the field. This is a chosen study bird because it is present here in Central Texas year-round, as you can see by the migration map. We wouldn't want to study a bird that is migrating in and out of this area, because then we might have a large decrease or increase in population during the study. We need the population to stay rather constant so that we don't introduce any biases into our study. We know what it looks like, but what does it sound like? Here is the song of the blue jay. Now, if you're familiar with birds, you might notice that it's not usually the sound they vocalize. Blue jays usually call more than often than they sing. Let's hear that call. Now, that probably sounds much more familiar. You've probably heard that at some point and wondered what it was. Now you know it's the call of the blue jay. The song is much more pleasant than that screech of a call, but that characteristic call makes it easy to identify in the field. Let's try to see if we can spot some blue jays. Is this a blue jay? Yes, absolutely. We can see a distinct wing bar, the shingled look, and that black necklace that we discussed earlier. Is this a blue jay? Of course. This is more difficult than the previous image. As you can see, the coloration is not as easy to see in the field as you might have thought. This is due to the fact that the blue color you see is produced as light passes through the feathers. It's not a pigment. This makes it challenging to see in the field, as shown in this image. However, we see the same characteristics of shingled feathers, wing bars, and a black necklace from the previous example. Is this a blue jay? No, definitely not. It does not exhibit the same key field marks that we discussed previously. This is an eastern bluebird. However, it does illustrate that there are other bluebirds present here in central Texas, and that we can't just rely on color or that flash of blue we see in the field. Is this a blue jay? Nope, it has none of the characteristics of a blue jay. This is a blue grosbeak. Is this a blue jay? It's a trick, isn't it? This is a blue jay. It does not show any of the typical blue coloration. However, we do see those standard wing bars and the black necklace. Is this a blue jay? Nope, this is an indigo bunting. It does not exhibit those key field marks, but just like some of the other birds we've been looking at, it does reside here in central Texas. So make sure not to confuse that flash of blue with the blue jay. Last one. Is this a blue jay? This one looks really similar, but it's not a blue jay. It's a Woodhouse's scrub jay. It does have the blue appearance, but is missing that black necklace and striations present on the blue jay. But it also resides in central Texas. Thus, it is important to learn the primary field marks so that you can easily identify your bird. It is also paramount that you can easily recognize their song and call. On to our next study bird. The Carolina wren. As you can see, the Carolina wren is present here in central Texas year-round, which makes it an excellent study bird candidate. Let's take some notes on its field marks. The most important thing about the Carolina wren is the color change between its upper part and lower part. The upper would be described as rufous, which is reddish-brown. The lower would be described as buff. This color contrast is very useful in identifying this particular bird. Another key field mark is the white throat and white eyebrow. A behavior characteristic of wrens is to hold their tail up, which might also be useful in identifying this bird, but not always the case. You will use these key characteristics to help identify this bird in the field, but what about its vocalization? Here is the song of the Carolina wren. A mnemonic that might help you distinguish this is tickettle, 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 a quick repetition of notes. Here's the call. As you hear, it is a very raspy sound. Sometimes it is also accompanied by a chirp at the end. Ignore that high-pitched chip, though, that you hear in the background. That is the sound of another study bird. Make sure to practice using the Cornel site. Let's try our game again. Is this a Carolina wren? Nope, it does appear to be if I'm looking at the general shape. However, you see that it does not exhibit that rufous and buff contrast common to the Carolina wren. This is a Bewick's wren. It is also present in central Texas. However, it does not sound like the Carolina wren. You want to test your ears to ensure that you can differentiate between the two. On to our next study bird, the Carolina chickadee. Has a unique appearance, sometimes referred to as the tuxedo bird, or as students call it, the cutest of the birds. As you can see, it is found year-round here in central Texas. In terms of field marks, this bird does not appear to have any neck. It has this sort of tuxedo appearance to its face. You'll also notice that its tail is long in relation to the size of the bird. But what does it sound like? A very pleasant sound. A mnemonic that you might use to help remember this is Chickadee, Chickadee. Let's hear the call. You might think of this as a fast-paced song of chickadee-dee-dee, chickadee-dee-dee. It also has the behavioral characteristic of hanging upside down. Luckily, there are not really any birds that look like this in Central Texas, so it should be easier to identify. Our next bird is the sleek bird. This is the Tufted Tip Mouse. It is found year-round in Central Texas, but as you can see, it basically cuts Texas in half, appearing in East Central Texas. This will come into play later. This bird is a small bird with a dark black eye. It normally has this lifted crest, a black forehead, and a white belly with this patch of orange along the side. You can also see that it has dark outlined wings. When it vocalizes, it sounds similar to Peter, Peter, Peter. Let's hear it. Again, to help you remember this, think of it as Peter, 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 Peter. This sound sounds similar to the Carolina chickadee, so be sure to practice the two to ensure you can differentiate between them. Let's hear the call. A harsh rasp, usually punctuated by a high note at the beginning. Practice is key in differentiating between each sound. Let's try our game again. Is this a tufted titmouse? Yes, you can see that black forehead and raised crest, plus those deep black eyes. Is this a tufted titmouse? No, this is a black crested titmouse. As you can see, it has a black crest and not that black forehead like we saw on the tufted titmouse. However, if we look at the range, we actually see that this species and the tufted titmouse are split by the Bioconese Fault, with this species in the west and the tufted in the east. This is an excellent example of allopatric speciation, which we will discuss in our next playlist. This does cause complications. Sometimes these two species mate, resulting in hybrids, like this one, which does not fall into either category. Thus, for the purposes of our study, you will study just titmouses in general, as a whole, instead of differentiating between the two species and the hybrids. Next, we have the state bird of Texas, the northern mockingbird. As you can see, it is not limited to Texas, though. It covers most of the lower half of the United States. In terms of its physical appearance, the mockingbird is a slender songbird with an unusually long tail. It also has these two distinctive wing bars which help to identify the bird in flight. Let's hear it. What is that? It sounds like so many different things. Exactly. That is the key characteristic of the mockingbird. It mocks. This results in a song that is a mashup of various sounds that it has acquired from other birds or urban sounds. Here is the call. I want you to pay attention to the chip, chip sound and the murr, murr sounds. Let's see if we can identify it. Is this a mockingbird? Yes, if we look at the wings, you can see that distinct wing bar we discussed previously. Here is another view, again illustrating those wing bars. Is this a mockingbird? Definitely not. This is a loggerhead shrike. If you look at its beak, you can see that this bird is different than the ones we have discussed this far. It is clearly a characteristic of a predator, sometimes eating rodents, smaller mammals, or lizards. They are known for impaling their large prey on thorns or barbed wire to be eaten later, such as you see in the dragonfly in the image. I wanted to make you aware of this bird, 1, because it's cool, 2, because it can appear similar to a mockingbird. For instance, here, it appears very similar to a mockingbird. However, this is the loggerhead shrike. You see those same typical wing bars that we might have confused with the mockingbird. Thus, don't be confused by this in flight. Wait until it lands to confirm that it is either a northern mockingbird or a loggerhead shrike based on its behavior. Our last study bird is the northern cardinal. It is present year-round all throughout Texas. The northern cardinal is fairly large, long-tailed songbird, and has this unique short, thick, orangish beak, prominent crest that is usually raised. The males are brilliantly red. In terms of coloration, this bird is red due to a pigment, which makes it easier to identify than the blue jay. What does it sound like, though? Here is the song. A mnemonic that might help is furky, furky, furky. Here's the call. That is that distinct high-pitched chip that we heard in the background of another bird. Let's try to identify it. Is this a northern cardinal? This is a trick question. Yes, it is. This species of bird is the only one we have discussed that exhibits sexual dimorphism. The female is more pale brownish with red tinges in the wings and tail. You also see that same characteristic bright orange beak. Is this a northern cardinal? Nope, not all red birds are cardinals. This is a summer tanager, which is present in central Texas in summer and spring. So be sure not to mix it up with the northern cardinal. Is this a northern cardinal? Yep, another trick question. This is actually a juvenile northern cardinal. It appears like the female, but it actually has a dark gray or blackish bill. Well done. We've made it through all 6 study birds. Pause the video and take yourself a break. Next, we will review data collection and analysis. Welcome back. For our discussion of the research methods, we will be breaking it up into 3 sections. First, the inland strip method. Second, data collection, and third, analyzing the data. First, what is the inland strip method? This is the method that you are going to use for data collection. It consists of a transect or straight line that you're going to walk. The transect should be somewhere between 0.8 kilometers and 1.2 kilometers. For this project, you are going to walk the transect in search of your bird. You should walk at a steady, leisure pace. It should take about 1 hour to complete the full kilometer. As you walk, you will take note of any time you see or hear your study bird, up to 125 meters from each side. Thus, you need to practice estimating distances to ensure you can estimate how far away your bird actually is. You can place these transects along trails within your park, like the researchers have done in this example. However, there is one major thing to look out for. Since you are looking for birds on both sides, you don't want your transect to loop or bend too much. This will result in you recording duplicate data or the same bird several times. You want your transect to be as straight as possible, given trail limitations. For data collection, you will need to create a table like this for each collection. Be sure to record all necessary information about your transect accurately. This will be used much later in the project and you'll appreciate it. In regards to the Beaufort number and sky condition codes, these charts are provided in the resources module on Blend. You will see that you are recording each time you visualize a bird or hear one of its vocalizations. We will show you an example in just a moment. Make sure to record observations of human activity, animal activity, or other disturbances along your transect under the table. I would include how many times you see people, bikers, dogs, or planes. This can be used to further analyze your data, and you'll appreciate it as part of the conclusion of your project. You've got the data. Now it's time to analyze it. This can be very difficult the first time, or even the second time. Thus, be sure to use the practice problems in the resources module and reference this video later to ensure that you are performing them correctly. Each collection will require 3 calculations: the full detection strip, population estimate, and our coefficient of detectability. The full detection strip serves as an adjustment to the data due to the difficulty of detecting birds in the field. Here is an example of a completed collection table. To determine the full detection strip, we need to consider each piece at a time to determine if it qualifies for the full detection strip. We are looking for a decrease of more than 20% in the number of detections. We start by taking the average detections from 0 to 10. In this case, that would be the average of 10 and 9, which is 9.5. 20% of 9.5, or the average, is 1.9. Then we need to determine if the drop from the average to the next detection strip is greater than 20%. In this case, that would be 9.5 as the average, minus 8 the next detections, which is only 1.5. That is less than 1.9. Therefore, this is not the full detection strip. We need to assess more data. Therefore, we now take the average of 0 to 15 meters, which is 9. 20% of 9 is 1.8. Now we ask that same question. Is the difference between the average and the next detection strip more than 20%? Well, the average, in this case, which is 9, minus the next detections, which is 6, is 3, which is greater than 1.8. This means we stop, and this is considered our full detection strip. Therefore, the full detection strip for this collection is 15 meters. We must use this full detection strip to determine a population estimate of the area we are studying. To calculate the population estimate, we need a few bits of information. First, the max distance, which would be 125 meters, for that is the farthest distance we are recording birds. The FDS is 15 meters, which we just calculated. We also need the number of detections in the FDS. Ensure that this is just the number of detections in the FDS and not the total number of detections, which is a common mistake. The last piece of information we need is the area being tested. To determine, we need to look back at our study area. We are walking a transect and looking for birds 125 meters from each side. This results in a total width of 250 meters. The length of the transect will change depending on your location, but for this example, we will use exactly 1 kilometer. Therefore, the area of the study site is 250,000 meters squared, or 25 hectares. Now we just need to plug in the values. Therefore, we calculate that the population estimate is 5 birds per hectare. The last calculation, we will need to calculate the coefficient of detectability. This tells us how many birds we detected in our sample based on the population, the estimated population. It is the total number of detections divided by the population estimate. You get the population estimate by multiplying the total area of study by the estimated birds per hectare we just calculated. In our example, this would be 42 divided by 135, which equals 0.31. Great work, Velociraptors. That concludes our workshop on birds. I hope that now you've gained the skill set to be able to identify your bird in the field. Make sure to take the time to practice learning the different vocalizations of the bird that you are going to choose to study. If you have any questions, please reach out, and thanks for tuning in.